So before going into that, we will be needing the data sheet. So you see there are like two PDFs are there, the pinout PDF and the data sheet. The data sheet will be having details about what are the functionalities, very detailed descriptions of different components, connections over there. You can see, right? So there will be this pinout PDF is also kind of a quick look for different connections and different peripherals over there. So this is the chip, which is the Atmega 328C, and these are the uh, these pins are connected to different pins out there, right, in this breakout board, and how the connection is and which peripheral is connected to which pin. Those kind of details is there. This will be useful for us today. So we'll keep. You can just like type Arduino docs, and for the documentation, you will get this, right? For every board, you will have a separate pinout PDF. So just type out Arduino docs. Then you will have that. There you can go to the hardware section and select the Arduino. So this is the common. We have Arduino Uno R3. There you can. Okay. So now let's go with the GPIO. So let's see this pin out. You see here, there are digital pins starting with this D0 to D13. So like 14 digital pins are there. And here, these are analog pins. These pins A0 to A5, 6 analog pins are there, which you can see here, ADC, analog to digital converter. So these pins are internally using a ADC circuit to convert this analog circuit into digital, which means these analog pins are only possible for the input pins because these are connected to ADC. So these digital pins are like GPIO pins. We call it GPIO because these are general purpose input output pins. Means we can give digital input and digital output through this pin. Right? So we can configure one of these 14 pins to be the digital input. And there are different communication protocols are there, I2C, SPI, which we'll be studying in the later week. So while using these pins are dedicated for those protocols, which means the peripherals that are interacting with this protocol are connected to this pin. Right? Okay. And these LEDs are also connected to this CD5. You can see the internal LEDs are connected to TX and RX pins, which will show this data transfer then happening to this I2C protocol. The LED built-in is an LED which we can use to change that. By default, it will be connected to PB5, which means the PB5 is also connected to this one. Right? So PB5, these naming are the naming from the board pins. So the board pins connected to the chip pins connected to the Arduino pins. So these orange things are the Arduino pins, and these yellow things are the names from this pin, this chip. So the PB1 of this chip is connected to D9 of this Arduino breakout board. Right? So we should understand the difference between this microcontroller chip and the Arduino development board. So this whole blue thing is the Arduino development board, and this chip is the microcontroller. Okay, these pins are the microcontroller pins. That's why it's given micro. These pins are the Arduino pin numbers. So here with this Arduino library, we can mention the Arduino pin names itself. When we are using the Arduino library, we can use the Arduino pin names itself. Okay. So we'll be using one, two. Just for digital pins, we'll be just using the numbers. For analog pins, we'll be using A and analog number like A5, A4, like that. Okay. Okay. Yeah. I hope the pin configuration and what's the microcontroller and the difference between microcontroller and the development board is clear now, right? What is Arduino? Arduino is the development board. What is Amiga 28T? It's the microcontroller. Okay. So, so let's start with programming. So we are saying GPIO, right? So let's start with the output. Let's connect this to ground and let's add an input. Take a push button. Okay. So there are different ways in which you can connect this push button. One is in a pull-up mode and another is in the pull-down mode. In the Arduino board, pull-down mode is not supported. Only pull-up mode is supported. So we'll be connecting in that configuration. So you see this, how do we connect this button? So you can see this X-ray, like this lines going, right? So this wire is actually connected with this one, and this wire is connected with this one. When you press the button, these two wires join. So basically, by default, this button one L and 2L, 1L and 2L pins are not connected, and similarly, 1R and 2R pins are not connected. So basically, we can connect this whenever this button touches, it connects. Okay. So closing the circuit. So we'll set the input pin and we can give this to the ground. I can use any ground. I am just using this ground over here. You can use the same ground as here, which is fine, just to keep it diagram clean without overlapping and just okay. And now uh, let's see what will happen. So basically, this is an input. I'm going to set this as an input pull-up mode pin, and I'm going to set this as an output mode pin. So that we'll set it up. And also, we can define our constant. You can either use as define for your variables like LED pin. LED pin is 13, and fine button pin is 12. Then we can use this to set up this thing. Defining global variables is handy so that we don't need to global variables or preprocessor directives. This macro is like can be handy, so we can just name the pin instead of writing the pin number. If you want to change the circuit, you can basically change the pin number in this one place. So that way, it is more clean to have global variables or microprocessor, preprocessor directives over here. So now let's set the pin mode. So this is how we set up which mode does the GPIO pin operate. So these pins are GPIO pins. So let's say pin mode, LED pin, this output, pin mode, LED pin, sorry, button pin, input pull up. So input mode, when do we use input mode? We use input mode while we are taking input from one of these analog pins. So then we set the mode to input. When you set it to the input, uh, it should be active in some sense. So you should connect a active device. You can use for digital pins also, but it should be when the device this should be a active device that is supplying a voltage, kind of like that. Then you use the input. But here it is not an active device, it is just a passive device. So by default, we will connect it to the input pull up configuration. So what does input pull up mean? Let's come to this one. So by default, whatever value is present in this pin, we can read, right? So that is in the input mode. We can read the value in here, which means the voltage, actual voltage we can read here. So by default, input pull-up means I am setting this pin to input mode and I am going to set the default voltage in this pin to high. Okay, that is pulling up. So by default, this will be high. So all other pins, when you set to output mode or uh, input mode, it will be in a floating state. Output mode, it will be set to 0. But in input pull-up mode, it will be set to 1 by default. So it will be always 1. Okay. Uh, in a STM board, you also have an input pull down configuration, which will reset the input to low. So that is also there. Okay. So by default, for this Arduino board, we use the input pull up configuration. So in this pull up configuration, by default, the voltage here will be high, which is 1. Okay. So when I press this button, the circuit closes and it short circuits to ground, which means the voltage here becomes shorted with the ground and becomes 0, which is low. So when I press this button, the status here becomes 0 or low. When I don't press this button, this will be high. So it's like when I hold this button, it will be low. When I release this button, it will be high. Okay. So then let's see how we read the values. Now what I'm going to do is, I'm just going to do, whenever I press this, it should, when I hold this, it should be lighter. So I'm writing code for that. First I'll read this pin. Whatever value is there, I'm going to put that in here. Is that correct? Will this work? Yeah, so since this will be looping forever, I'll just add a delay of 10 milliseconds to increase the simulation speed. This is not required in a real environment. Okay, when I run this, uh, yeah, digital write to the LED pin. Right, we have to mention the pin number first and the status. So here it will read high or low based on the value present in this pin. Here that will write that value to the LED. But as you can see, it is high now, and when I press it, it is low because, as I said, by default, this value will be high. So that's why whenever you write the same value to the LED pin, by default, it will be high. When you press, it becomes low. How do we change so that this goes in the opposite direction? We add a not operator so that by default, it will be off. And when you press this button or hold this button, it will be on. Okay. So now we get to know the basics of the GPIO, how input pull-up works and output works. Right. So now uh, let's just focus on. So now what are how you can add many controls and many LEDs and uh, do it like that, right? So let's see how we can add multiple LEDs and multiple buttons and control each LED with each button. How do you improve this code? We use for loops, right? When you have multiple things like this, it's better you use loops to improve your code. So that way the code will be simple. So you can have, so you cannot use an LED array like that. So instead of going with pre-transfer directives, we'll go with global variables. You can have LED pins. So let's say 4 pins and or let's say 1, 2, 3, there are 14, right? Uh, 14 pins, so 7, 7. So let's just the values 13, 12, 11, 10, 9, 8, 7, 6, 7 is right. Ah, and we can have button pins. Um, sorry, uh, 5, 4, 3, 2, 1, and 0. Okay, so now we'll update this code with for loops. So there are 7 pins. So I can set it in a single for loop itself. So this when this whole for loop completes, all the pins would have its respective node. Then how do we do this? We want to all the pins buttons to have the corresponding values. So we do the same thing again in the same for loop. So this is a for loop inside this uh, big while loop that is happening there. Okay. Now what is remaining? Anyone? Is the code complete or shall we run the simulation? We haven't added the buttons yet. So how are we going to do that? You can click these buttons and do that, or you can go here and directly edit the circuit diagram and add the connection. So how do I add more LEDs? Copy paste, and I'll change the LED ID numbers to 2, 3, 4, 5, 7. So I'll move everything by uh, okay, this looks better. 30, right? 60, 90, 0, 20, 50, 280. Let's change the colors to okay, fine. And now add the connection. The cathode will be connected to the ground. Two, three, four, five, six, seven. You see how everything got connected to the ground, right? You might not see it properly now. So let's also increase this height of this. So just increasing all the LEDs a little high. This is just that. Okay, let's also adjust this. This is okay. Okay, the diagram looks a little cleaner. And now let's add the other connections to the button. Sorry, the pins. Okay, 2, 3, 4, 5, 6, 7. And we'll connect that to the different pins. 12, 11, 10, 9, 8, 7. But this will be a little messier, but I guess it's the best we can do. Now at least we can see uh, things are going to different things. So the LEDs are connected. Now let's connect the buttons. For that we need to create the buttons. So you can like play around with editing these diagrams also. It will give you an idea of how this what we use this diagram.json to create images. So because instead of dragging everything from here and putting it all together, this would be an easier way to edit the uh, diagram.json to get some neater looking diagrams that way. Let's add buttons. Now let's just change to button 1, button 2, 3, 4, 5, 6, 7. Let's change the colors to according same with the buttons. Green, blue, sorry. Oh, okay, let's just change according to the colors of the LED. Red, blue, green, yellow, orange, purple, and pink. Okay, so now let's change the position. Okay, adding 50, 106, 156, uh, 200, 256, and 306. Maybe we'll lift everything a little higher, right? So you hold shift and select all the components, and you can uh, we have one wrong component. More push button is there. Purple, orange, green, red, button 1, 2, 3, 4, 5, 6, 7. I think that is we have everything. It seems to be some other thing. I'm holding shift and then this. Now the circuit looks okay. Okay, so now we'll start connecting this thing. Okay, and this will be here. It's doing it by hand, I guess. Okay, we connect the ground using copy paste. This is the ground, right? 1, 2, 3, 4, 5, 6. This will reduce the overall. It should be 40. It will reduce 100. So 90, 140, 100, 40, Then we'll do the same. I think this is good enough. Okay. So now we have our connections, also our LED. Let's see. Is there any error here? Yes, we have to declare them as RH. Okay. Now let's start. So you can see I have a these outputs are coming because we have connected some to the RX and TX pins, which are primarily used for the serial monitor, right? So whenever I send signals to those pins, the TX pin, which is one, you can see some random things is getting printed in the serial monitor, right? So don't worry about that. Okay. Uh, so now in WASPI, you can also do one thing like assigning a keyboard key shortcut. So see this one? So this has been assigned to the shortcut for the push button key. So this key component can be used to set the shortcut key. So I'll just put this. So basically you can control the push button with your keyboard key, the number key. So I'll just connect uh, my keyboard's number keys, 1, 2, 3, 4, 5, and 7. So now I could just basically control the whole simulation with my keyboard keys, right? So what is interesting to see building something like this? The- Did you understand how this works and whatever things we did, changing the diagram.json, editing the code? It might look complex, but this is something fun that you can do. Okay, so now let's save this. So the good thing is you can even modify this code, like removing all the LEDs and using buffers. You can make a piano, right? You can make a piano like that. I'm just saving this. With 7 keys, you can have an octave and then basically uh, play some simple songs. So you can try modifying this. There are no auto sizing option. Distances manually. Yes, manually you have to do. Otherwise, you have to write a code to auto generating the layout. So if you have a very structured layout, you can write a code. So just like what I did, I increased 50, 50 every time, right? So you write a code to generate this JSON. Using Python, you can generate a JSON systematically or programmatically like this. It's easy. You can just do a Google search on how to create JSON in Python or doing things like that. Yes, sir.
Sir, can you repeat the for loop part?
This one.
Yes, sir.
So basically, we have the 7 LEDs and 7 pins, right? So we have to read values from each of these pins, each of the corresponding pin, and update the value for the corresponding light. the LED, right? So this pin, so in the first, when I is equal to 0, it will take LED pin of 0, which is 13, and the button pin of 0, which is 6. It means it will read the button pin of 6, this one, which is connected to the red button, and then will change the set the status of this this one, right? Digital write, what it does, it writes the values since it is output pin. So LED pins are output pins, right? It takes the output pin and writes this value, whatever you have. So we are reading from the this button. So I am reading value from this button and negating it because we have connected it in full of configuration. So when I press the button, it will go to 0. So I have to change the sign. So I am changing the sign, reading that, and updating the corresponding pin. So for which button I am pressing, the same LED I have to change the state. So how this actually runs is, each time this loop, outer loop happens, this for loop also happen every time. So every time, it's not like when you press, this line executes. This keeps on executing. Okay, this will like, for example, if you slow down the simulation to the each instruction step, even though you hold multiple buttons at the same time, it all the LEDs are not turning on at the same time. So here, when I run the simulation, oops, when I run the simulation, you will see that it is, oops, you will see that even though I press all the buttons together, you see all the LEDs turning on, right? But it is not actually the case. This keeps on running, and at one instruction it will turn on only LED, and the next instruction it will turn on the other LED, depending upon the set the status. But this happens so fast, so you see that it happens at the same time. But the thing is, it takes time. So to demonstrate that delay, I can add an internal delay of like 1 second or 100 millisecond. I think it will be visible. Let's play again. So now even if I press all the buttons at the same time, oops, you will see the one, uh, only one will turn on at the same time. So let's say, you see the delay. So because of that delay, even if I press all the buttons, first four buttons at the same time, you can see the delay in turning on. Okay, because it first reads one value, writes value, waits for 100 milliseconds, then reads value, writes value, waits for 100 milliseconds. It goes like that. So once this all the read and write has been done, then this loop runs whole again. That's how it writes the state. So if you are doing a long running, this is what we call polling. I am constantly checking what is the value in the button and then updating my state, right? So I repeatedly doing this again and again. So in the first code, simple code, I just looked into the one pin and update the state again and again in the outer loop. Since my this code, I have 7 pins, I have to do all that for that number of times, right? Every time I have to check the button of each button state and update the LED state. Check the button state, LED state. After once completed, then again go check the button state, update the LED state, like that. That's how the program flows. Do you get that?
Okay, sir.
Was that clear? Are you still having trouble understanding? Yeah. Okay. That is the that's how this program flows. So in each loop, one statement happens, and it happens. It checks the value from the button pin and updates the. So now this is what we call polling mode. So this happens in the main loop. So So the main loop goes on going, and we read value, constantly check the value and update in the programmatical flow itself. And this process is called polling. So there is another way of execution where you can say that doesn't work with all the buttons, only specific buttons you can use that. In that mode, certain inputs you can say so that when I press this button, only when I press this button, some other things going to happen, and then it will change the flow of the code or something like that. It won't keep on constantly checking for the value of the button, but in that flow, which we are calling interrupt, when I press the button, there will be a separate block of code that so the main loop passes, and there will be a separate block of code that will get executed, and then it comes back to the main loop. This kind of flow is also there. That's what we call interrupts, right? So now let me just create a simple thing. I'm just going to do I, and I'll just take this delay. We do need, since we internally have a delay there, low. So now what do you think this will do? First turns on everything and then turns off everything like that. So kind of looks some like looks like it's running, right. This is something that you can do. Mm, Now can we say this is due to a delayed mode of execution, right? Now let's say there are like two modes of execution. So here it goes from 0 to 1, and it goes from here to here, right? Mm, So can we combine this logic? Let me check. So now this is basically checking, like changing only one pin and then introducing a delay. Instead of this, we'll set the states of all the pins at the same time and then change the states uh, after every delay. So I'm just going to rewrite this code in a different way. Mm, Let me check. Let me have a variable uh, j. Okay. So this j will go from j or this j plus equal to or j equal to j plus 1. It always increases. Okay. And also I'll be rounding it, sorry, uh, modding it with mm, 7, since we have 7 lights. Okay. This is one. This is like, I think this is going to be a different code. What I'm going to do is, if uh, I equal to j, I will be writing I else I'll be writing low. So how this works is, neat loop, it turns off all the lights except the jet light, and then I'm adding the relay, right? Relay. So it's basically only one LED is blinking at a time. Since the delay is too small, you kind of feel it going forward. So what happens if I do minus one? You'll see it's going in the it will be going in the reverse direction. Uh, I think I can go that way. Let's say 7 plus. I think this would be more correct. Ah, now this makes sense, right? So when I do this, it goes in the reverse direction. When I do that, it goes in the positive direction. Now I can alternate between whatever direction I want, if I want, by changing this value. Right? Now I can set, or I can call this direction itself. So if the direction is set to -1, this will keep on going in the reverse direction. The direction is set to +1, it will go on the positive direction. Now I can uh, set this one of these things to change the value of dir while the loop is running. So this will keep on running. But I need another part of the code that will be get executed whenever I press the button. Another function will be called out of nowhere, and that is how interrupts work, right? And that function will change the value of dir to -1 or 1 based on the button input. And then the whole flow, after finishing changing that value, it will come back and continue this loop. That's how interrupts work. Okay. So for that, first we'll go through this one. Let's see. Let's go to the advanced section. Yeah. So Arduino interrupts, you can use these two buttons, D3 and D2, for the Arduino interrupts. Only these two buttons are allowed for the external interrupts, as we call them. Or because there are different kinds of interrupts are there, but ones that are introduced by these buttons are called external interrupts. There are like different types of interrupts like timer interrupts and UART interrupts. Different things are there, but we'll be studying today only the external interrupt or the button based interrupt. So whenever the button is clicked, it will come. So to do that, we'll also go to the language reference. Here you will see the interrupt related functions. See this one? For interrupts, have this. Sorry, this is for enabling and disabling the interrupts. Uh, External interrupts. Yeah. attach interrupt and digital pin filter. Detach, I think we don't need now because we'll just set it up and then it will continue forward. So how do we set a pin to interrupt? So each interrupt will have a number. Basically, this function will convert that pin number to the interrupt number. So that's why this function is needed. Right? So basically, we use it like that. Uh, not like this. We use it basically like this. We convert this interrupt pin to the interrupt number, and then we'll attach interrupt and the function that will execute and the mode of when to trigger the interrupt. So here we have different modes. So when this interrupt will happen, that is given by this. ISR is the function that gets run whenever that event happens, and it's the pin number. Interrupt number, as you can see here. So you put it like this. So now select this. So we'll select pin 2. So how do I set up that? Attach interrupt, digital pin to interrupt, and the pin I will be setting up will be uh, pin 2, let's say that, and then the function, let's say, change there will be the function. I will be writing that function, and when should it come up? So when I press this, what will happen? When I press this, it goes from high to low, which is falling. Okay, so I'll set it up. So when I press this, it goes from high to low, and then this will be triggered. Okay, so I'll write that function. Before that, I'll put everything here. This will be a void function. And now I will just have to do z equal to minus z. So if it's a positive one, it will turn to negative. If it's negative, it will turn to positive. Right. The button 2 is the third one, which is the orange button, which is connected to the button 2. Now let's run this. Okay. This, this should work. Now when I press the button, it changes the direction. When I press it again, it changes the direction again. Okay, that's how interrupt works. So the main functionality will be happening again and again. But why this is important? Why can't you do this change in uh, direction there based on the button press? Assume this is already running in polling, right? So I have to hold this button till this whole thing happens. After it comes and checks this button pin, and then it should update the status, right? Change the direction. So if this is a long running code, running this at the end, so if it has delays, running this changing direction at the end will not make it happen until it comes. So when do we run a long running program using polling? How do we listen for short events and change the values in between? You can change the value of direction anytime, at anywhere, whenever this is there. So even if there's something is running, before finishing that, we can change before finishing all this thing, we can change the interrupt. So maybe I can slow this a little bit. So if I am just changing this direction at the end of this loop, it has to wait till the end and then it changes the direction. But with interrupts, you can change the direction in between also. That's the one major advantage of using interrupts. So you see, now it goes right. Now I can change without even completing, change the direction with this interrupt, right? Okay. So is that clear how interrupt works and polling works? For polling, this main loop, whatever we mean, the main loop will check the data and do the things. But here in interrupts, we do something different. So maybe for this demo, you don't need the other push buttons over here. I just refresh it for that. Um, you don't need. You just need that for one button, which is button pin. To pull up. It can be also button pin. That's it. And I think that's the most code change that we need. And the circuit diagram change, we'll remove the other LEDs except the orange one. Okay. We'll also delete the connections correspondingly. Maybe I'll switch with green button. And we'll okay. So any doubts, anyone? this exercise. I will share this also. You can practice uh, and try to understand this also. Okay. And there is some particular thing about push buttons are actually there that we'll deal in the next class. And this is the thing called bounce. So sometimes when I press this button, you can see it kind of triggers twice when I run this. You'll see that thing. When I press this, I think button 5. Right. Sometimes it doesn't change the direction because sometimes triggers twice. You see this? When I hold, it's happening. When I release this also, it is happening. But it shouldn't happen when I release, right? It should happen only when I hold. Why is that happening? Because of the bounce. So when I release, there is a small bounce that is happening. This also has like multiple implications. Basically, when you touch, it will kind of repeatedly uh, press itself when the bounce is turned on. But when we stop bounce, it will behave like uh, ideal button. So when you release, nothing will happen like that. So when you press, it happens, and one press onward. So we'll check out how bounce behaves and how we can handle that using interrupts and polling. So there are different ways which you can handle bounce based on how you have connected the thing. Whether you have using the button for interrupts mode or polling mode, how do you get the exact value from the button so that you do something called as debouncing. That we'll see in the next class. Okay. And after that, we'll also see analog things you can pretty much easily get. So in the next class, I'll also share some other practice problems where you can see analog inputs and other things. Okay, everything's clear. Any doubts? Any doubts between polling and interrupts? Do you understand the concept of polling and interrupts? Okay, okay. So if there is nothing else, we can stop today's session. Thank you for that.